Finally, we're going to talk about properties of alkenes very quickly. We've talked about properties of alkanes, and alkenes resemble alkanes in their properties. Generally, they have low boiling and melting points, especially when they are small, when they have a low molecular weight, and they have very small dipole moments, if any at all. However, when you have an alkene that is substituted with a heteroatom, it does have a significant dipole moment. So when you have something with like a chlorine attached to a double bond, you can have a strong dipole, and that's because this chlorine cannot rotate, remember? So you have a fixed position where we have a strong difference in dipole and electronegativity, causing in general the molecule to have a higher dipole moment. Generally, when talking about dipole, any alkyl groups attached to a double bond appear to be electron donating or electron releasing on the basis of the dipole moments. So here we have a propene where we have a methyl group. This is going to generally have a very small dipole change when we have this substituent. However, when we put on some type of additional electronegative group like a chlorine, this will pull electron density, which then causes the additional methyl groups to also donate electron density. You can see how this electron density is actually being donated if we look at the resonance structure of a molecule like this. You can see that there's hyperconjugative donation of electrons from our alkyl group, causing there as a resonance structure to be a double bond at this position and electron density now at this position. Again, this is a minor contributor in resonance, but just showing you this resonance allows you to kind of visualize where that electron density is laying in this type of dipole. In general, trends with alkenes and their stability are also influenced by several factors. Firstly, steric crowding. So cis isomers are usually destabilized when you have interactions between close groups. An example of that, you can look at cis-2-butene versus trans-2-butene. Notice that the cis version is less stable, and that's because the two big groups are on the same side, whereas here the two big groups are on the opposite side. Generally, when looking at the same version of a molecule, the cis version will be less stable because of these steric interactions. Additional alkyl groups bonded to a double bond also generally stabilize the double bond. So when you have, the more groups you add to a double bond, the more stable the double bond is itself. So if you wanted to compare our butene here, the trans butene, notice that there are groups that are on one group on each side of the double bond. So a methyl group here and a methyl group here. And compare that to our 1-butene, in which we have one group on our double bond, that is an alkene, but the rest of the groups are just hydrogens. So generally, these butenes that have two methyl groups or two alkyl groups on the double bond, as opposed to just one alkyl group on the double bond, increase its stability. Lastly, chain branching itself on alkenes actually makes it more stable than the less branched version. We see that when comparing these butenes, for example, to 2-methylpropene. Notice this double bond has the same number of alkyl groups attached to it, in this case 2, but when you have them on the same side like this, in a branching manner, they're actually more stable than when they are on opposite sides, whether it's cis or trans. Okay, well, that's it for our alkene discussion. Remember, we've talked a lot about our naming of alkenes and especially introduction of this E and Z system. So make sure you're comfortable being able to name some of these molecules, especially ones that are now going to combine rules that we've talked about. For practice, I actually suggest that you use something like ChemDraw and just make a practice molecule, try naming it yourself, and you can actually, remember, use that naming function that ChemDraw has to check yourself and see if you have gotten your answer correct. So next up, we're going to be talking about reactions of alkenes and specifically the elimination reaction.